So, good afternoon. Thanks very much for coming along to this last session of the conference today and bearing with us till the end. My name is Spencer Harbour. I'm an architect, SharePoint architect based in Edinburgh in the United Kingdom. My contact details there on the slide. Should there be any questions or queries that we don't cover in the session or we don't get time to discuss towards the end, and a bunch of alphabet soup there that isn't really relevant to what we're talking about today. So this is an IT Pro Level 300 session, and we're going to talk about the new request management capability in SharePoint 2013. I'm going to try and make this a demonstration-heavy session. There's always a risk in doing that in terms of how long or how well my machine performs when it's actually on stage. But we'll talk through the fundamentals about request management, in other words, what it's designed to do for us and what type of scenarios we might choose to use it in. We'll take a little bit of a look at the architecture of the system and then dive into each of its components and how we configure them. As I mentioned, I'm going to present a demonstration which provides an example scenario. It's not a scenario that you would deploy in the real world. It's one that's been contrived deliberately to showcase the configuration and management and capability. It's not meant to be, a best practice or something that you might copy. It's done deliberately just to show things. And then we'll wrap up with some recommendations towards the end. So hopefully that's the session you were expecting. If not, you've got a chance to get out before it's too late. Let's talk about, what is this thing called request management? So fundamentally, this is a service instance in SharePoint that allows the SharePoint system as a whole to understand more about the nature of incoming HTTP requests. Now, we have to always bear in mind that this is only useful to us when we are talking about HTTP requests. It's no use for any other type of request. And that's a fairly key takeaway at this stage from a high level. And by having knowledge about the incoming requests, such as what type of client application has made the request, the location of the request, and so on, allows us to do some interesting things in terms of how we choose to respond to that request, if indeed we choose to respond to it at all. So in simple terms, that's really all this is about. We have a very high degree of capability in terms of what we can configure this to do, but in a nutshell, it's basically a capability that allows us to change the response based on characteristics of the incoming requests. If we choose to implement this feature, the first decision that request management is going to make for us once it's in play is to decide if the farm should respond to a request at all. Right? We might want to configure the system to refuse certain types of requests. So that's really the first decision that will be made. And then, if we have chosen to respond to a particular request, we're going to figure out, which web server in our environment is going to handle that request and how. And it's basically a rules system. So we have the ability via PowerShell to configure a set of rules which will dictate the usefulness or otherwise of the system. So we can deny requests if we don't like the look of where they're coming from. Perhaps we could, deny requests based on a referrer if we're in a public-facing website scenario, and then route the requests that we do want to respond to the right machines, therefore allowing us to do interesting things from an operational service perspective in terms of performance and capacity management. So I've put together a few slides here that will talk through some usage scenarios at a high level in 4 areas in terms of where request management might be useful to us. And these usage scenarios will probably give you a pretty good indication of, what type of deployment this feature is going to be useful for and, what types of things it's intended to address. So the first one is reliability and performance or throughput of the environment. So being able to, by default with SharePoint, every request is going to go to a machine And one machine in the farm might be suffering a performance problem. It might be underpowered in terms of physical resources, or it could be, having some problem based on a customization or so on. And if we continue to send requests to that machine which is suffering poor performance, from the end user's perspective, we're going to increase the latency of that connection and, in most cases, actually going to time out. So that's not really an acceptable experience from the end user's perspective. So we can leverage request management here to route the requests to the machines that have got good performance characteristics to avoid this problem. Another example which is in the similar space is if we have a SharePoint environment, we're going to be serving different types of usage clients. So we'll be serving regular end users, but during certain times of the day, we might also need to respond to requests from a search crawler, for example. And in SharePoint 2010, in a default configuration, both the end users and the search crawler are getting equal priority in the farm. So we might not want that. We might want to say for the search crawler, we could deny the requests completely, and then they wouldn't have any negative impact. Or we might push them to other machines that maybe have different hardware characteristics. The next area is in terms of capacity management. Request management in and of itself doesn't provide us with a tool for capacity management in SharePoint, right? There's no magic silver bullet for capacity management, but it does allow us to be better at managing capacity requirements. In the standard configuration in most environments, all web servers are going to want to be able to handle any requests, and we don't really care which server it's going to. So we can use this rule system again to configure different groups of machines that will respond to different types of requests. We can also leverage this to finally implement the logical concept of server groups. So we might dedicate certain machines for search crawling, other machines for the Office client applications and those kind of things. So we can use the machine pools capability to finally actually have an implementation of the idea of logical server groups. And in terms of scalability, we have a couple of very common customer scenarios and also scenarios from hosting environments whereby if we have a very large-scale environment, the overhead of the management of an external to the SharePoint farm load balancer can be a real scalability limiter. And so we can use request management as an application routing capability and let the load balancer do what the load balancer is best at, i.e., doing the balancing of load at the network level, and leave the application decision-making process to request management. We might also be in a situation where we don't have the resources in terms of finance to be able to continually scale the external load balancer. And we may wish to be able to add more hosts to our environment, but we've already got the maximum number of hosts on that external load balancer. So again, we can use this feature to route requests across multiple SharePoint farms, independent of the load balancer. So just to help me out a little bit in terms of when we get to the demonstration and so on, how many of you here are running a SharePoint deployment that uses some form of load balancing today? Okay, good. You're in the right room. You've all got the same question, I think, coming up towards the end. But how many of those of you that raised your hands are running Windows network load balancing? Okay, interesting. What about an alternative product from another vendor? Yeah, so that's good. And I'll show you that later on, what the implications of using both together are and what we need to consider there. Then the last sort of scenario in terms of potential usage is around the operational service management or keeping a farm running well. So if we have a server failing or is responding to requests slowly for whatever reason, we can use request management to temporarily send requests of certain types to different machines. And this allows us to more easily, as an IT pro running a farm, identify the root cause of problems. There's also kind of a side benefit to this. If we've deployed some customization into our environment and it's not working on one machine, we can use this to allow, a highly skilled developer access to an individual machine to try and troubleshoot the problem. Now, you wouldn't do that, as a general statement. You wouldn't work like that in a production environment, but, sometimes you have to get to that level, and this can help in those type of scenarios. So those are 4 sort of buckets of where request management can potentially help a deployment. Let's switch now to a brief look at the architecture of request management. It's pretty simple stuff. It's a SharePoint Foundation feature, so it ships in every SKU of the product. It's turned off by default. Unless you have a good reason to turn it on, leave it off. Just like everything else in SharePoint, there's no negative footprint of impact here by just installing a farm. And fundamentally, this is very important, fundamentally these settings are scoped on a per web application basis. And if you are going to go down the road of using request management, this will have impact on your information architecture and deployment planning, because it's going to change potentially how you do your IIS addressing for your web applications. So we have our SharePoint web server. That's running the SharePoint Foundation Web Application Service, which is commonly referred to as a web front end. Within the web service, the request manager runs. So it's very important to bear in mind that the request manager lives in w3wp.exe. And there's 3 components to the request manager. There's throttling and prioritization, so filter out the requests that we wish to deny, and then prioritize the ones that we wish to respond to. And then we route the requests, so select a group of machines, a group of web servers, which may respond to that request. And then the load balancing aspect of this, determines the individual server that should respond to the request. Now, for this all to work, we also need the request management service instance to be provisioned. So whilst the request manager itself lives in the web application process, we need the request management service to be there for operational purposes, and also this is our point of configuration. Okay, so we need this running before we can configure the rules. So the request manager is the first code that runs in response to HTTP requests once this is turned on. We can enable routing or disable routing by a configuration property, but this will always run if we don't do that. And this is implemented in the SP request module. So there is a little bit of impact there once we start the service. As I mentioned, it runs in process on the web server, and what that means is we must be running, if we have a farm with 3 web servers, or WFEs, I don't like the term, but that's what everybody calls it, so we'll use it. On each of those 3 machines, we must also be running the request management service instance. But there's no point running that service instance on, the search server, for example. It's not going to serve any purpose. Then we're going to configure request management to run effectively inside one web application. As I mentioned, the settings are scoped at the web application level. So for this to work, IIS must be listening in order for request management to process requests. How many of you here today with SharePoint of any version implement your web applications using IIS host headers when you create them? Yeah, so most of you, about 75%. Now, if we do that, we've got a host header. So if we want to serve more than one application with a fully qualified name, this isn't going to work. We're going to have to configure request management on each web application individually. So there's an impact here around the move towards using web applications with no host headers and using a thing called hostname site collections. So the intended deployment for request management is exactly that. A single web application with no host headers in IIS, which is where request management is configured. But bear in mind, that web application may not be the one that's actually hosting the content that the user is requesting. Okay, we might be sending it to a different farm or a different web application. This doesn't mean you cannot use request management on a web app with host headers, but that significantly complicates the configuration and management. So the strong recommendation here, and this is a general recommendation as far as SharePoint 2013 is concerned, i.e. move towards host-based sites. It's the preferred logical architecture approach for SharePoint going forward. The example that I'll show you was slightly different than in the demo, but the example on the slide here is we can use hostname site collections to implement these multiple top-level sites in a single web application. If we do this, it's really important to remember to always create a site collection at the root of the web application. No end users will ever access this web application, but if it's not there, the behavior of SharePoint is slightly different, and it's also a support requirement for this root site collection to exist. So request management has two modes of deployment. The first deployment mode is integrated, and this is deploying request management on all the web servers in a single farm. And this is really going to driving towards the common on-premises deployment. And then there's dedicated mode, which is a SharePoint farm whose sole purpose in life is to route requests and run the request management capability. The content is hosted on additional farms, which this guy sends the request to. And this, as you might imagine, is naturally intended to the large-scale hosting environments. So a couple of architecture diagrams here. This is our integrated mode deployment. We have a network load balancer of some description. Doesn't matter who makes it or whether it's hardware or software or squidgyware. That's going to send requests to a number of web servers, which are all running request management, and request management is also speaking to each of the other web servers in the farm to understand their availability and so on. And then to contrast that with the dedicated mode deployment, whereby the load balancers are going to send requests to the request management farm, and then the request management farm will route requests to the individual content farms on the right-hand side of the diagram. A little reference slide here which compares the deployment modes. The diagrams should kind of present this as well. If we are using dedicated mode, it means that we can scale the content farms independently of the request management farm and vice versa. Whereas if we're in integrated mode, that's not possible. If we need to scale that farm for whatever reason, we've got to add more web servers. That means we've got to add more, they've all got to be running request management as well. We can't tune the resource usage in terms of memory, CPU, and so on for an integrated mode deployment as well. We've also got the sort of independence from the addition of the product. In the dedicated mode diagram, that request management farm could be running SharePoint Foundation, right? Because that's all it's doing. It doesn't need anything else. But also, importantly, there's a dependency on our IIS bindings. If we're in an integrated mode deployment, we need to make sure that the web applications on those web servers are going to be able to, respond to requests and make sure we don't get mixed up there with our bindings. Whereas in dedicated mode, we don't care about that. It's not relevant. Okay, so let's move into some of the more details-oriented aspects. There's a number of key components to the overall subsystem. So the first one is a routing target. And sometimes within documentation and the PowerShell, this might be referred to as a machine target, but they're effectively the same thing. And this is a web server, right? This is a box that's going to respond to requests. And we have a couple of weightings that can be applied to the routing target. The first one is a static weighting, which we as the administrator can assign and say, this machine is more important than this other machine. And then there's a health weighting, which is the SharePoint health score. And so we can do things based on a threshold, say that this rule is only going to be triggered when the health score gets to a certain number. Then we have machine pools, which is a collection of routing targets. And this is the target of routing rules. So our routing rules don't point to an individual server, they point to machine pools. Then we have our rules. So there's two types of rules. There's a routing rule. This is basically the definition of a criteria to evaluate before sending requests onto the machine pool. And these are obviously assigned to a machine pool as well. And then there's throttling rules, which is the same thing, but this time is the criteria to evaluate before simply refusing the request. Okay, so these are the requests that we want to turn away. And these ones, because we're refusing the request, obviously they don't need to be associated with a machine pool. And our routing rules live in execution groups. The execution group is simply a way of allowing us to have the evaluation process include precedents. And we have 3 execution groups. We can't change this, we can't make them 5, we can't reduce them, they're just hard limits. And they're named execution group 0, 1, and 2. And then there's the rule criteria, which is simply the types of things that we are going to check for, and this is all based on standard HTTP properties. So the rule criteria allows us to evaluate one of these 8 headers or properties. So basic things like the URL, the referrer, the user agent, so that would be the type of browser or client application, the host name, the IP address of the client, whether it's GET or POST, those kind of things. And we also have the ability to use custom headers. So if we wanted to extend this based on some custom client application coming down the road in the future, we can do that. We have that sort of extensibility point. And then for each of those properties, we have 4 match methods that we can use. And they're basic string comparison operators, so starts with, ends with, equals. And then we can also use a regular expression. Now, regular expressions are fantastic. They're extremely powerful, but with that power comes a great deal of responsibility. The one thing that can tank your farm here is a badly authored regular expression. In most cases, the regular expression could be replaced with a smarter rule based on one of the other operators. So there needs to be quite a lot of caution when using these. In fact, we don't, we're that scared of these guys that we give you a little orange warning when we configure them. So how are these rules evaluated? I mentioned earlier that we have execution groups. Before we get to those, we are going to check the throttling rules. So these are the first things that are evaluated. And if any throttling rule is matched, then the request is just simply refused, right? It's just denied. If it isn't matched, so if the incoming request doesn't match a throttling rule, we will then go ahead and evaluate the rules that are in, or the routing rules, I should say, that are in execution group 0. And, if we match a rule, then we will route the request. And at that point, no further execution groups are evaluated. Now, this is very important when we come to plan and operate any deployment of request management. If we don't have a match, we'll go ahead and evaluate execution group 1's rules, and then again for execution group 2. Now, if we get to the bottom and we still haven't matched, then it will be sent to any available routing target in the farm. Okay, so a little animation that shows this. This is a sample configuration. We've got 3 throttling rules, 7 routing rules, and a bunch of SharePoint machines in 3 machine pools. So, if nothing matches, then it will go to any one of those 8 SharePoint servers. But what happens if that rule there, routing rule 2, is matched? What that means is the other rules will not be evaluated. So we need to be careful about which execution group we put our important rules in, otherwise they may not be executed, or evaluated, sorry. And so we end up in a situation where the requests are being served by the wrong machine pool. So to reiterate these 2 gotchas, as soon as a match is found, no more execution groups are evaluated. So our really important rules must be in execution group 0. That's an easy way of guaranteeing they will be evaluated. And if no rules are matched, we will send a request to any available routing target. So we're not going to just sort of deny the request. We're going to pass it across to anyone. So if we want to do the idea of server groups that I mentioned before, i.e. subsets of machines for certain types of operation, we're going to create a rule that doesn't have a criteria, and that will then be associated with a machine pool. Okay, so if we look now at the configuration and management of this feature, it's very straightforward. We go into Central Admin, we go into the config wizard, and there we've got the request management configuration wizard. No, I'm sorry, we don't have that. They didn't get time. This is 100% from now on is Windows PowerShell. Everything we do with this is going to be Windows PowerShell. So I've got a few slides here, and I don't want to spend too long on them, otherwise we'll run out of time for the demo. They're really more for sort of, your reading pleasure later on when you can't sleep or whatever. Just to point out the key commandlets that we're going to be using. So the first one, the top level sort of configuration object is all of the commandlets, star.sp request management settings. This is our configuration parent. This is the guy that's scoped at the web app. So when we get one of these guys, we're going to pass in the URL of the web app, and that will give us our settings object, and we will then pipeline that into the other commandlets to make configuration changes. So this is the big daddy, as it were. You can just see an example there on the slide where I've got my web application. I'm just going to get that, and then I'm going to pipe it into get SP request management settings, and that retrieves on the right-hand side a bunch of properties. And some of these are changeable. So I have routing enabled there, which is the third one down. So I may choose to turn off routing, and you can see a few things there related to the internal ping mechanism. And you can also see in the routing targets, which is on line 20 there, the free machines in my farm, in my sort of sample farm. So once we have this settings, RM settings in this example, then we can then go ahead and use the other commandlets. Oh, that's an interesting animation mess up. So the first thing is machine pools. So this allows us to configure the machine pools and their routing targets. This example, we create a machine pool called the primary machine pool, and we add in two servers, SPO1 and SPO2, and then we add that machine pool to the settings. Then we have routing machine info. I mentioned that, this kind of a little bit of inconsistency there with the naming. This is how we configure routing targets. If we are leveraging or we are deploying in dedicated mode, we cannot actually do this. We're passing in a string array here of server names. Well, that only works for the machines that are in the farm you're working with. So if you're in a dedicated mode deployment, we need to leverage this guy, the routing machine info. And it's very straightforward. We can get the routing machine info and we pass in the name of a server. We can also set some properties. In this example, I'm setting the static weight of this machine to 9. Then we have the management rule criteria, and this is where we define the criteria for both throttling and routing rules. It's a very simple example where I'm going to use a regex. You shouldn't do this, right? But I'm checking the user agent HTTP property, and if it contains Microsoft Office OneNote 2013, then I'm going to make some decision based on that. So this is very simple. We just have the property and user agent, then there's the match type, and then the value of the match type. Now, if I really wanted to do this in the real world, I would do equals. And I might have more than one rule for the various different versions of OneNote that are in play. That would be much more efficient than doing a regex like this. Then we have throttling rules. So naturally allows us to configure throttling rules. There's an example on the slide where I've got my same criteria, and then I use add SP throttling rule, give it a name, and then add the criteria to the back of that. And then we have a rule active. I can also do so with a threshold on the end. So in this example, it's the same as the one above, but this time I'm just going to say this only kicks in when the health score is 8. Then we have the same thing for routing rules, but the only real difference here is we're going to also configure their execution group. If we leave the execution group switch off here, it will always go into execution group 0. I would recommend here, as just a general statement, is get into the habit of always specifying the execution group. It just makes it a lot more easy to work with. So those are the key commandlets. We'll see them in the demonstration in a few moments. Once we've set this up, we need to be able to monitor it. For anything other than a really basic deployment, like the one I'll show in the demo, we need to be on top of these rules and make sure that we are in a position to be able to be confident that everything is operating as we want it to. So there's a number of ways we can monitor the system. Naturally, we have ULS logs that are going to give us a large amount of detail, and we can ratchet up the sort of verbosity of the information that's presented here. And there's a category we can use for filtering purposes, and that's, unsurprisingly, request management. There's also our Internet Information Services log files, which are commonly overlooked here. We can see the ping mechanism happening in there. We can also see the raw HTTP data that will be reflected elsewhere in the system as well. And then we have performance counters, which is probably the best way to understand operational service management characteristics when we're using request management. So we have a new set of counters named SharePoint Foundation Request Management. So I have an example scenario which will walk through the key configuration aspects. It's a fairly simple thing. We have a single SharePoint farm. Therefore, I'm obviously running request management in integrated mode. In that farm, I have 3 web servers. I didn't have any good ideas for naming, so they're called SP1, SP2, SP3. And these are being load balanced using the Big IP Local Traffic Manager product. And then I have 3 hostname site collections, one for Contoso, one for Fabricam, and one for AdventureWorks. And I've sort of concocted some, completely bogus business requirements to show the feature. I want to deny or refuse all of the requests from my OneNote client application. The OneNote client is kind of heavyweight, and during certain periods of the day, I don't want that to have a negative impact on performance, so I'm going to refuse those requests. For no good reason at all, really, other than to show the feature, I'm also going to make sure that requests for PDF files are always going to come from SP1 and SP2. I've got nothing against PDF files. Well, I kind of do, but I won't really go into that. But it has no relevance to this thing. It's just a way of easily showing the execution group precedence. Then the request for AdventureWorks site collection, that should be served by SP1 and 2. Requests for Contoso are so special, right? They're the biggest company on earth, right? So they need their own web server, right? And this is the world's, biggest web server, the most memory. It's all SSDs and everything. So I wish, but anyway, they're special, so they get their own web server. And Fabricam will go to the other 2 machines. So that's what I want to sort of deploy. So here's our logical architecture, how we can implement that. To meet those requirements, I need 2 machine pools down the bottom. One called the primary machine pool, where my machines 1 and 2 are. And then I have the Contoso machine pool for that wonderful web server. Then I need 2 execution groups, because I need to make sure that my PDF files are served from the primary machine pool, even if they're in the Contoso site collection. Okay, so they must be evaluated first. Otherwise, that rule would never match, and they would be being served by the wrong pool. Then the other rules can just go in execution group 1. And of course, I have a throttling rule at the top there, which is just going to immediately deny requests from the OneNote client. Also note on the diagram for the SP2 machine, I've assigned that guy a static weight of 9. And hopefully we'll see in the demonstration that once I have done that and we've fired some requests at the machine, the majority of the requests in the farm are going to be served by SP2 because it has a higher static weight. Okay, so let's take a look at this demo, and we should be okay for time. I will switch in a second. Okay, so the environment I've got here is 3, 4, 5. This guy's gone to sleep, so I need to start that up. Serves me right for talking too long. But I've got quite a lot of virtual hosts running on this laptop, so This is the sort of thing that works great when you're in the hotel room the day before, and then when you do it on stage, it might slow down a bit, so we'll just have to see how it goes. Okay, so here's my central admin for the farm. It's fairly straightforward. I've got my free web servers. This is the default configuration, after I've created the farm using PowerShell. So I'm running the web application service and the distributed cache on the free machines. I have my single web application here, SharePoint hosting, and there is no host header, right, for this web application. So it's listening in IIS on all unassigned with no host headers. And then I have free hostname site collections hanging off that guy. I've also got the root site collection at the top of the list there. But that's my AdventureWorks, Contoso, and Fabricam. Here are the site collections, just using the basic team site template. Change the colors so I know which one I'm working with. Here's Contoso. Here's a couple of PDFs. And there's Fabricam, who've got a crazy color. And if we switch over to a client machine here, I can go into the load balancer configuration. I need to log in. Sorry about that. So here's my load balancer. I'm going into the web administration interface here. If I go into my application pools here, you can see I have a pool called SharePoint, and I have my free servers. Take my word for it. 7 is SP1. 8 is SP2, 9 is SP3, so those are my free SharePoint servers, and they're all available at the moment. And so, I'm doing classic load balancing here. They are not sticky sessions, so any request could go to any machine. If I go ahead and refresh a bunch of these requests, we should be able to, see that. I'll just go over quickly onto a couple of the other machines and do the same thing. So if we bring up the dashboard here, we'll be able to see that traffic. Down here, so you can see, I've got my free nodes and a single pool there. And if I go to the pool, you can see I have 26 connections, a total of 49 connections there, which was just me, going from each of those machines and hitting up the requests. And if I go to the individual web servers here, the first one, which is SP1, is doing 15. SP2 is doing 19, and SP2 is doing 19, SP3 is doing 15. So just so that, to clearly explain that we are doing classic load balancing here, there's no sticky sessions, I'm not fiddling around with my host file for the purposes of the demo, anything like that. Okay, so the first thing I need to do is turn on request management. Now, obviously I can go ahead and do that over in Central Admin, come over into Services on Server. It's just in here, Request Management, and just start this guy. There's no service application involved, it's just a service instance. But I need to be able to ensure that this guy is running on every web server. So I'm going to choose to do this with PowerShell instead. And I've got a couple of functions here which allow me to get the machines in the farm that are running the web application service, then loop through those and start request management. So we'll go ahead and try that. And this will take a few minutes for these guys to provision. So whilst that's doing that, we'll come over here, have a look at the servers in farm page, and eventually when these guys are provisioned, we should just be able to see them show up in here. So you can see this guy started, and it's just going to do the next two. Should just be another minute or so before this finishes. Now, at this point, the request management service is running on a couple of the servers. If I open up my IIS log files and just check this, no, we haven't kicked in yet, but we will see the date, the time and date stamp of this last file change as request management kicks in and starts pinging each of the other machines in the farm. That's going to generate, a lot of logging into this file. If you're wondering about the date, that's the current time and date in Edinburgh, so that's why that's all wacky. It's not that we've been here too long or anything like that. Okay, so we're good. This is now started. The next thing I need to do then is grab my request management settings object. So I'm just going to pass in the web application to get SP request management settings, and then I'm going to write that out to the screen. So it's the same stuff that was on the slide, very straightforward. We can look in here, and I've got some of this stuff's already populated, so routing is enabled. I've got free routing targets, and there's some ping timeout values here, intervals, and so on. It's interesting that that file hasn't changed yet. We'll leave it be. Okay, so the next stage is to create a couple of machine pools. If you remember from the diagram, we need two machine pools, one which includes SP1 and SP2, and then the one for Contoso. So this is the commandlets to do this. I simply give the machine pool a name, and then pass in a string array of servers, and then call add SP routing machine pool. So we'll just run these two. And then I can output the machine pool configuration here. And you can see both of them are created. And you'll notice that the order they're displayed in is the opposite of the order they were created in. So it's a last in, first out kind of thing here. Once I have my machine pools, I'm going to go ahead and configure some routing machine properties. Do you remember that one machine I wanted to provide a static weighting for it? So we can get a machine properties simply by passing in the top-level settings object into get SP routing machine info with the server name. That will display the machine properties. You can see, the static weighting by default for every machine will be 1. So I'm going to change that to 9, and then I'm going to output the same command I just ran to double check. Always get into the habit of validating what you've just done step by step. That's a key thing to working with these commandlets. Or, well, for that matter, any commandlets with SharePoint. Okay, so the next thing I'm going to do is add my throttling rule. It's also a good practice, because throttling rules are evaluated first, we should probably get into the habit of creating them first. So I have my rule criteria here where I'm going to refuse the requests from OneNote, and I'm going to use the regular expression. Just before I do that, I'm going to flip to the client machine here and load up OneNote and try and open one of the sites, just to prove that I'm not, sort of canning this. So I'm going to go to any one of the site collections, doesn't really matter which one. And there'll be a little delay while OneNote figures out that I'm asking for a website rather than a file system. A little delay, famous last words. There you go, and it's prompting me for credentials. Now, I have deliberately configured this machine in a fashion that puts this up. In the real world, I'm signed in as Miles Davis, who's a domain user. They wouldn't see this pop up. But this is a very important point, right? It doesn't matter what type of authentication you are using. Request management doesn't care or know about that and is not going to interfere with it. Okay? So we'll log in as Davis M. And eventually, this should come back up here and show me the libraries in the site that I've just connected to. There we go. So right now, it's working. So we'll go back over to the PowerShell here, and we'll create the throttling rule, and note that we're using the regex that I told you not to do. And, well, that was quick. You can see here, it's giving us a warning. Regular expressions are, could be quite expensive. Maybe you should consider using one of the other match types. And that's it. That's all we need to do for that throttling rule. I'm now going to go ahead and create the other rules. So this one, I'm going to change this up a little bit from the previous example. I need to assign a machine pool here, so I grab that guy, pass it in. This time I'm going to match. I'm going to do a regex again here. Even worse way of doing it, because it would be easy to do this with ends with, of course. This time, if it matches PDF or .pdf on the end, I'm going to serve it from the primary machine pool, which I grab. Oops. What have I done wrong here? Oh, nothing. And then I add this to the execution group 0, as I mentioned, another kind of little recommendation there. And this is all, I'm repeating this process for the remainder of the routing rules. I've got another couple here. This time I'm using the equals match type, and so if the address is www.fabricam.com, it'll go from the correct machine pool. So I'm just going to run through these quite quickly, create these rules, the remaining rules, I should say. Oops. And then what I can do at the end is validate my rules. So just have a quick look-see here, after I've configured, to make sure that I've got the ones I want, that they're named correctly, and so on. Can't see the criteria at this point. It would be reasonably easy to just change this up a little bit to drill in there and select the criteria, but I'm fairly confident that these are correct. Then I'm also just going to double-check the top-level settings. And you can see now the difference from when I ran it initially, right at the start of the demonstration, that here are all my routing rules, my throttling rule, my machine pool, and so on. So at this point, we've configured the system. The next sort of step is to try and validate that this stuff actually, is functioning. Before we do that, let's have a quick look at the logs again. This guy's still not updated. It's gone to sleep. A bit worried about that. Let's take a look at one of the other machines. Same thing here. Well, it's not happening right now, but these were the tests that I were doing earlier this afternoon. So you can see the ping mechanism here from earlier today on the machines. I'll load up ULS Viewer, which allows us to see what's going on. Of course, I'll load up the real-time trace, and I'm going to filter the category on request management. You can see we've got a bunch of stuff coming in here. It's loading the routing target count, the target count before throttling, the final target for a certain request, and then you can see a lot of these guys where I'm mapping the incoming URI from 10.0.0.7 to SPO3. Now that's interesting, because 7 is not SP3, right? 7 is SP1. Remember, the load balancer is not doing sticky sessions. Request management is responding to the load balancer's application pinging mechanism, and then responding with a response from another physical machine. So that's a key consideration when you're deploying this guy, to understand what changes you will need to make to the mechanism used by the switch or load balancer to do its application monitoring. And that's the stuff that the switch people are selling you, right? So that's very important to understand. There's a very tight interrelationship between these two things. You need both if you're in the scenario buckets that I described earlier, but we need to design the deployment so it takes into account all of these things. And I'll show a little bit more of that towards the end. So there's a lot of that stuff going on here. Just to make it a little bit easier to see what's happening, I'm going to further filter the logs here and ratchet back the level, because I've deliberately changed this up. This is the maximum amount of stuff that we can see. So this is verbose, and I'll just throttle it back in ULS here now to medium. And you can see all that's happening at the moment is that the load balancer keeps doing a HTTP request to each of the machine, and request management is responding to those requests based on the rules that I just configured. But none of my rules are matching, right? Because the load balancer is not using the fully qualified name. It's using the IP address. So request management is basically making its own determination which machine in the farm the response will come from. So let's go ahead back over to the client machine and try a few other things. I need to close this, actually. I need to close this one as well. Come back in, open up the site collections again, and let's go ahead and do that on a couple of other machines as well. So I'm just simulating, a bunch of end users doing stuff and just refreshing these pages, basically. Flip back over to here, and you can see now these are the end user requests. And if we look in the top here, I know it's quite difficult to see that we're mapping the request from www.fabricam.com to SP2. Okay, so one of the machines in the primary machine pool. And the reason it's SP2, of course, is because the static weight I assigned to SP2 is 9. So in this environment, with the one user that's using the system, most of the responses are going to be coming from the SP2 machine. And I've also got the performance monitor counters. So I'm going to add these in here, and you need to bear with me whilst I point and click a little bit here. This is kind of fiddly. Oops, went too far. So here we go, we've got SharePoint Foundation Request Management. And this is neat. So if you're familiar with performance counters, some of them, you need to be collecting them from all the machines in the farm from some other management machine. In this case, I can actually just go onto one machine and use total. So, I'm going to be getting the counters for all the free machines in the farm. You wouldn't do this in the real world from one of the web servers in the farm, right? That would be kind of stupid. But for the purposes of demo, it actually, helps quite a lot. So we'll just add all of them there. And I'm just going to change a couple of them so that it's a little bit easier to see. Not exactly perfect, but good enough for our purposes here. Oops, that's a bit too far. Okay, so you can see some activity here in the farm. I'm going to highlight the current one. These are the requests that have been routed, and those were the previous requests we made, and there's other stuff going on. What's going on here? It's the load balancer that's pinging the web servers. Okay? And then the blue line, which is now highlighted in white there, is the ping latency, the aggregate ping latency of the free machines in the farm. If I go ahead and go to my client, let's refresh all our tabs again. And if I'm quick enough, you can see we have this spike here, which is those requests being routed. Let's go ahead and try the OneNote thing again. Let's test that request is being denied. Now I'll use a different site collection, this time Fabricam, so we don't get any caching weirdness happening here. Again, it should prompt me for credentials. And then once it's authenticated me, it's going to bail, right? Because OneNote doesn't know anything about request management. As far as it's concerned, it's just having its connection terminated. So I'll get a generic error message there. I don't have any good explanation for why that always takes so long. And I put the wrong password in. It's been a long day. There we go. Let's get it right this time. It's such a complex password, that it's quite difficult to remember. And we should just get a generic message box come back here that says, you can't open this location using this program, please try a different location. Now, obviously, that's not very helpful to the end user, but we're doing a brute force termination of the connection at this point. So there's not really any way that OneNote would be able to present a more user-friendly message here. That's kind of the intent. Okay, so let's do one more thing to sort of reiterate the point about the importance of understanding, if you are going down this road, what the relationship between your load balancer and request management is. If we get rid of OneNote, had enough of that, and we go back to our load balancer administration here, and bring up the machine pool again. So what I'm going to do is I'm going to say that my servers SP2 and SP3 what's going on here? Oh, hidden at the bottom. I'm going to disable those guys, right? So I'm effectively, what I'm effectively simulating here is, for whatever reason, I'm saying that SP2 and SP3 are undergoing maintenance, so I don't want them responding to requests, right? So now, at least if I'm thinking in the old classic way of doing these kind of deployments, then those machines are not available to end users and they're not processing requests. But the reality is they are. Okay, just because I've removed them from the load balancer doesn't mean that request management is not going to process the rules I just configured. So, we can open up, do a few more requests and so on. Let's go and get that PDF file, for example. These are not good PDFs, you don't really want to read them, but they're just samples there for the purposes of this. And if we switch over to here, you can see, these are the same statistics that we get. There's our ping mechanism. But if we look in the ULS, for the end user requests, they are still being routed to the other machines in the farm. Yeah. Most of these are one. So that's a pretty key takeaway here, or key thing to understand. I should actually see in here, I'll do the OneNote one as an example again. It's the best way to force that to update. To wait for this to wake up. I love how I have to click more now just to find my browse button. Okay, so that rule is still active. Of course, haven't changed anything there. And you can see that, this is now reporting that the request has been throttled by the throttling rules. The reason it didn't show up in the ULS previously was because that was happening on one of the other machines in the farm, right? On SP2, because that's the one with the static wait. So that's it in a nutshell. We've seen how we start the service instance. Oh, I need to switch, sorry. We've seen how we start the service instance, creating machine pools, routing targets, throttling rules, and routing rules. It's fairly simple stuff. But the danger is, because it's so simple, it's very easy to make a right mess of it. Which brings us to the wrap-up. It's a very powerful capability to potentially improve our operational service management capability in, the areas of reliability, performance, scalability, and capacity. It doesn't replace the load balancer, right? In the very smallest environments, and that's not even really true, but in environments where you only have 2 web servers, you could potentially make an argument that this would replace something like Windows network load balancing. But that's not the intent here. This is application-aware throttling and routing. You can think it's easier to think of this in comparison to something like the IIS application routing capability. Right? So it doesn't replace the load balancer. You're still going to need the load balancer because this guy's a software proxy. Right? It's not going to be able to handle the throughput you want for typical load balancing scenarios, especially in internet-facing deployments. It's entirely optional. If your customer or yourself can't, articulate a good reason why you want it, a problem that you could use this to solve, you don't need it. Leave it off, right? If you ask a customer, would you like your farm to have better reliability, performance, scalability, and capacity, you're only ever going to get one answer, right? Yeah? Nobody's going to say, nah, I don't need any of that. Right? Except maybe Contoso, right? Because they're so special, they've got the world's most, kick-ass internet. But we need to get deeper into, what problem are you trying to solve, and articulate that, and then make a decision about whether request management is right for you or not. The planning of the rules is easily the most important thing once you've made the right decision to use this guy. A single bad rule, a single rule in the wrong execution group, from the perspective of your end users, can cause the entire farm. And so by doing that, by making a typo, a single one-character mistake in the configuration of the PowerShell that I just showed you, could mean you have drastically reduced reliability, performance, scalability, and capacity, right? So it's not the scalability slider in central admin that perhaps some of us might have dreamt of. Avoid the use of regular expressions as much as possible for the rule criteria, right? In a lot of cases, especially when we're working with standard HTTP properties, virtually all scenarios you can think of can be achieved with starts with, ends with, and equals. Regex is there to enable us to do, that very little bit of niche on the edge that it does incur, if it's a badly authored regex, a significant performance penalty. Also, if you're going to be looking at this, it's another feature in the product that very much is designed and architected to work when you're using a single web application with no host headers and using host name site collections. The other thing to take away from this is a note on the PowerShell. You've seen me run through a bunch of commandlets, and there's the reference in the slide. It's not about understanding the individual commandlets. It's about understanding how you combine those together, how you compose those together to get the solution you need. If you've got what I just demonstrated, 4 or so rules, a very basic configuration, you would be able to sort of just manage that in an ad hoc fashion. But if you're a hosting provider and you've got 50 rules and numerous machine pools and farms, it's not good enough to just have a snippets file and be executing those things manually. You need to think about how you compose those commandlets together in the right order so that you can validate as you go and so on. You need to be able to manage the configuration once it's in flight. A few of us are thinking about potentially producing a .NET client application which would provide a user interface for managing the rules. But the trouble with doing something like that is what I might think would be a useful composability model would be completely unapplicable to somebody else's deployment. So it's not about understanding the syntax of the commandlets, it's about figuring out what's the best way to combine the commandlets together. In other words, the playbook for the configuration and ongoing management. It's very common in the SharePoint world for the PowerShell aspects to really concentrate on what needs to be done to make it work. What we really need to think about, the very reason we have PowerShell in the first place, is to run operational service for the life cycle of the deployment, not just that first couple of weeks that you're provisioning everything in the first place. Also, make sure to plan the coexistence with your load balancer. You've seen in the example I showed you was using the local traffic manager from F5 Networks. You'll have similar considerations if you were to use the likes of Cisco and those kind of devices. And indeed, if you are using network load balancing, whilst that doesn't have an out-of-the-box ping mechanism as far as HTTP is concerned, you probably should be doing that with network load balancing, so you'd need to think about the coexistence there and understand what might need to change in terms of the procedures on how you run operational service. Right? If you're relying on the trick that I did, which was disable a couple of nodes to take them out of service, you need to rethink that approach because they're not out of service. They're still running perfectly okay and they're responding to requests. And obviously, as I've said quite a few times, this feature is not intended to replace your load balancer. So just in summary, to wrap up, we've got some additional resources. If you want the scripts that I've shown you, there's a 3-part series. The link's on the slide here. I assume you can all get the slides from the MySPC, but this is a 3-part article series which basically talks through the same scenario that I showed you in the demo. So if you want the PowerShell, that's where that's at. TechNet has configuration guidance, got a bit more information on the monitoring aspects of what I showed you, and Steve Peshka has also got additional PowerShell scripts which may be useful if you want to play with this feature and get a bit more detailed there. Okay, so with that, I'd like to thank everyone for staying so long, so late today. We've got about just under 10 minutes, so if there are any questions, please feel free. There's a couple of free microphones in the aisles there. Please use those so they're on the recording. Otherwise, you're free to go. Thanks very much. Hey. Cheers. I'm going to the Ask the Experts. So.
Question, Spence?
Correct. Go ahead, whoever it was that was at the mic.
Yeah, over here.
Thank you.
Can the request manager redirect to itself to actually handle the request response process?
Sorry, could you repeat the first part?
Can request manager redirect to itself, to the server it's on, to handle a request response process?
Yeah, so if the right machine to respond to that in a request is the one that it's evaluating it on, yeah, that's a member of the machine pool and is treated as all the other machines. So if you want that one to be the one that responds, that will happen. Yeah, if you've configured it that way, that will work.
Okay, thanks.
Okay.
The scenarios which you explained about the benefit of the request management component enabling, the first scenario, which is server health and the scalability monitoring part, like first scenario, that is common for everyone. Everyone would love to have that benefits. But apart from that, if we don't have any business justifications or any advantage of other scenarios, do you recommend to enabling this component?
No, I mean, you wouldn't, unless you have specific requirements where this is going to provide value, you stick with what you know and do well today, right? If you just want, classic load balancing, for lack of a better term, and you have the experience or expertise in doing that, and you don't have any other requirements that are driving you to look at some of the throttling and so on, then you stick with what you know works well. There's no. This is a capability. This capability is there and available for you to use, but is always going to be a value call about how you solve the particular problem. This is just another option to consider. So I wouldn't recommend you in that scenario. I wouldn't recommend using this when you have, you don't need any of the throttling. You don't need really the routing in terms of, different types of host name and things like that. So stick with what you know works well and performs well and so on.
Okay, thanks.
Yeah, can we? I don't know if there is anybody on that one. Just keep. Okay. Whoever talks loudest wins, right?
Can this be used to actually block like any kind of Active Directory OUs or any kind of geo-location type of blocking? Where I could use a rule to block, say, either a country or of users that are in an OU?
Yeah, so there's no native sort of interaction or understanding of the organizational unit that a server's in, so you're not going to be able to leverage group policy to do smart things here. You could potentially do that with a custom header. That's quite a lot of work. probably wouldn't go down that road personally, at least I wouldn't. So there's no real knowledge or understanding there. You could achieve the same end goal, but you would have to, they would be independent systems. There would be no relationship between the group policy or the container that the servers are in and the request management rule configuration. So.
Thank you.
If you have conflicting rules in the same execution group, does one get done first?
Yeah, so they're evaluated in the descending order they were added to the execution group.
Okay.
Yeah. But even if we match let's say we've got an execution group with 3 rules, right? And we match rule number 2, we're still going to evaluate rule number 3. It's just the other execution groups that don't get evaluated.
Right.
Yeah. Yep.
In one of your rules, you used the health index of a server to decide which way to go. Is there any standard guidance, I guess, on how to do that kind of routing, whether it's even with conventional load balancing on CPU and memory usage, for example?
Yeah, so I mean, it's not directly, it's kind of indirectly related to, the hardware resources of the machine. That health score is not something that we can influence other than doing kind of nasty things to the server. So all of the guidance in terms of the health score that we have today on just regular web application throttling, in terms of understanding that, is valid in terms of understanding where that number comes from. But bear in mind, that web application throttling, whilst it's certainly useful to a certain degree, it requires the client application make a decision based on it, and most client applications just simply ignore that health score, right? So it's just basically being used by request management because it's already there. There's no point creating another one. One common thing to do with this would be to create your own operations manager scripts that, based on certain characteristics of the server that are being collected, you would change the static weighting, and then it would use that.
And I guess where the question is going is, in the past, I mean, like if you have CPU over 80% for more than 5 minutes, maybe you might take that machine out of your loop for a while. Is there any standard guidance on that type of load balancing that is better than round robin, for example?
No, is the short answer, because it would be very difficult to put that kind of standard guidance and have it be generic enough. That would be the realm of the operations manager management packs would give you the best starting point for that. So those were pushed out a couple of days ago. You download those rules. That would be kind of the baseline to start with, I would suggest.
Okay.
Very difficult to get. No matter who produced those, they would get a lot of abuse for not being applicable for the...
I agree. It's a hard problem to solve, and it's something that, unless
Yeah.
you have a lot of experience and expertise with doing it, where do you start? That's the question. Great. That's a good place to start.
Okay.
Thanks, Spence.
Thank you. Let's go over to this side.
Yeah, from a networking perspective, I mean, the routing, is it based in a redirection, or is really, routing from one server, to another? Is an HTTP redirection via the end user?
I'm sorry, it's very low, this mic over here. I can hardly hear the gentleman. Could you repeat?
Yeah, from a networking perspective, I mean, the routing is an HTTP redirection?
Well, yes, you can think of this as a software proxy. Okay, so the incoming request is, to contoso.com, and then we are translating it to, SPO1, SPO2, SPO3, whichever one. And then, that's effectively the way it works. It's a software proxy in that respect. Yeah.
Okay, thank you.
But it's not redirection, it's more translation. Yeah.
So this means that the request is not going to back to the user, to go...
No, there's no round trip back to the client application.
Okay, thank you.
And in the middle, sir.
General guidance now is not to create farms that stretch across data centers. Mm-hmm. Is it still recommended not to do that for a dedicated request management farm? Or could you use that to route traffic to the local data center if they each got a copy of a published web application?
Yeah, you certainly could. That wouldn't be a good idea. Yeah, I mean, the geographic deployment aspects here, it's not really related. The design model is that the request management farm and the content farms are in the same data center. You would run into the same support boundary if you attempted to do it across the wide area network. whilst, in principle, there's nothing wrong with, sending the HTTP request across data centers in the same way that a traditional, network load balancer would do, but that's not our deployment model for request management. So, yeah, you don't want to go there. Any more over on this side?
If you need to encrypt traffic to the web front end, are you able to terminate the SSL at the web front end and use request management service? Or
yes.
Do you have, yes.
Yes. The easy answer is it works completely independently of whether it's port 80 or port 443. Just you're good.
Okay. Thanks.
Last one over here.
In the case if we want to quickly take one of the nodes out of the rotation, what's the best way doing that?
Yeah, so I would remove, well, there's two ways, and you can't really say that one is better than the other, so it's kind of 50-50. I would remove the machine from the routing target from the machine pool. And you can set thresholds on that, actually, and expiry and those kind of things. So you've got quite an amount of flexibility there that I didn't show you. That would be my preferred way of, removing something from the pool available. In kind of the same way I did with the switch there in the demo, right? That's the way I think of things would be that approach.
Thank you.
Okay. In the middle?
What were some of the problems that Microsoft was running into that they decided to include this feature?
I'm sorry, I couldn't hear.
What were some of the specific problems that Microsoft was seeing that they wanted to include this feature in this version?
Scalability is the main one, right? Because, well, there's two. I don't want to speak for for online because I don't work there, but the scalability of the switch it's not a limitation of the product, but it's there's a cost implication, there's a management implication. There's also being tied in to a particular, switch model. There's support considerations in terms of support lifecycle. And basically, I could do 60% of the things I showed you in the demonstration on the switch, right? But to do that, I need to know TCL, right? To do it in request management, I need to know a couple of commandlets, right? So there's an ease of rapidly changing configuration, especially if you think about it from an on-premises perspective. The chances that internal IT manages and operates the switch are pretty slim these days, right? It's usually somebody else. And so it's those kind of things that are in play more than it being, this particular technology can't do something, if that makes sense.
I got a question. The sticky session that you put on the load balancer, we have a application that uses Trusted Identity Provider, and we need to get back to that same web server because we established the session with it. And how does this play in on that? I mean, if we use this feature.
Yeah, so this feature doesn't really care about the stickiness or otherwise of your sessions. So in other words, the affinity mode of the load balancing scheme being used. Because we now have the distributed cache in SharePoint 2013, you no longer have that issue with trusted claims providers.
Oh, okay, where you would be re-authenticated. If you didn't end up back on the same web front end and you got routed somewhere else, you'd be re-authenticated. Well, you don't have that issue with a dynamic cache now?
Correct.
And I saw you had that turned on, right? That was one of the... Where did I see that? You started things up and I saw dynamic cache. Oh, yeah.
Right, yeah. So
on central admin, right?
Yeah. By default, when you add a machine to a farm, it will be running the distributed cache service. That's probably not the topology you want in the end analysis, but, look into the details on TechNet of how to design the topology for the distributed cache. But that is, that's the App Fabric stuff, right? So that's a SharePoint version of App Fabric that helps address the cookie issue with trusted provider.
Okay,
authentication.
That's good. I like to be prepared. We have a lot of architects in our company that they'll present this as an option. I want to better be prepared to see if it could be used. And it sounds like we could because it's no longer an issue. But whether we should is different. I mean, we're trying to use we have the F5s and we're trying to use those to do, it's not round robin, it's really least load is what they're using.
Yeah, so. Yeah, it's a very common scenario for all of the customers that are using claims off today with 2010. So, yeah.
Thank you very much.
No worries. So I'm afraid we need to get out of here. If there are people with other questions, we can do them as I wander through to the Ask the Experts.